Good morning to everyone. Today, welcome to this session about word problems, no problem. Today we are in session 1 of 3. So today we're going to focus on attack strategies for word problems and the additive schemas. And so today is going to start out as foundational, and then we're going to build on that on Wednesday. And then by Friday, we'll be talking about how to help students set up and solve multi-step word problems. But we have to start small to then be able to grow to get big. So as Cami said, my name is Sarah Powell. I am an associate professor at the University of Texas at Austin, but I have a connection to Virginia. I spent 2 years at the University of Virginia from 2011 to 2013, which is how I met a lot of people at the Virginia Department of Ed and continue to do a lot of work to support students who experience difficulty in math with a lot of teachers in Virginia. A few things that I want to share with you today. This is my email address, so if you do have any questions, please email me at any time. I have put this entire presentation on my website. I just put the link into the group chat. You can click on there and you can download this presentation, which I hope you will do if you want to make notes on it as we go along, or if you want to share it with others, or even share some of these things with your students. I've also put a handouts packet there. I'm going to do some word problem solving today, so if you want to print that out and do the word problems along with me, you're welcome to do so. I'm also on Twitter and only tweet about math things, so maybe we can become Twitter friends. And that's it. I work every day on trying to improve the mathematical outcomes for students that experience math difficulty. So in the chat box, that's whenever you see that little computer, I'm going to ask you to use the chat box. Just briefly introduce yourself. So tell me maybe what your name is, where you're from, and what grade levels you support in math. And then we'll move ahead in about 30 seconds or so. All right, and those will continue to come in, and I will look at those, especially afterward, to really get a good idea for where we're going on Wednesday and Friday. So today we're going to talk about the first session of word problems, no problem. So if you do have the handouts nearby, but I will always be showing screenshots of these, the first thing I'm going to ask you to do is look at a typical this is a middle school example, a middle school word problem, and what students are expected to do with this problem. So if you see this problem here, I would like you to take a few seconds to think about, well, what would your process be for solving this problem? And then because of your process for solving the problem, what skills might be necessary to solve? So take a little bit of time to think about that, and then we'll debrief as a group. All right, because we only have an hour today, I'd like you to start to think about, well, what are some of the skills necessary to solve this problem? You don't need to put them all in the chat box, but just give me one or two. So what are some of the things that students need to be able to do or need to know in order to solve this word problem? So Dana talks about reading. Christine talks about adding fractions. That's correct. Knowledge of fractions, Tanya brings that up. Samantha brings that up. So adding and subtracting fractions. Deidre talks about multiplying fractions. Elizabeth talks about understanding fractions as a part to the whole. And Terry brings up understanding proportions and being able to reduce, simplify, see? Joanne talks about understanding fractions and reading comprehension. Yep. So a lot of fraction knowledge is necessary to solve this problem, but I think a lot of you are also getting into some of these skills that are outside of mathematics. So reading comprehension, understanding, what are some of the words here that are important to understand? So we have to differentiate between caramel and chocolate and coconut and sprinkles. And Jessica brings up, well, what is this question really asking them? And so really focusing in on being able to answer the question. So you can see with a word problem like this is actually a pretty straightforward word problem. There's not a lot of irrelevant information in this problem that students have to ignore. There is a lot of calculation work that they have to do with fractions, but overall it's pretty straightforward, yet you all are providing me with lots of skills that are absolutely necessary to solve this problem, and with each of those skills that is necessary to solve the problem, that's where students can experience difficulty. So as we get started today, I'd like to talk about really the 7 areas where we see students experience difficulty with word problem solving the most, and you might be able to add this list to expand it upon 7. But when we look at a word problem like this, one of the first areas of difficulty where we see a lot of students have difficulty is in reading the problem. And so several of you mentioned this. So how do I read this problem? How do I interpret what this problem is asking me to figure out? And there's a lot of words in this problem. I haven't counted this up specifically, but in the middle school grades and into high school, an average word problem has usually about 29 words that a student has to read. And so if we're thinking about students that experience math difficulty, they also often experience reading difficulty. If we have dual language learners, and if we think about that, that every time they see a word problem, they have to read and digest 29 words and sometimes up to 100 words in a single problem, that's a lot of reading that could cause difficulty for students. So one of the first areas of difficulty before we've done any math is reading the problem. And then tied to that is understanding the vocabulary. So what vocabulary is important in this problem? Here we have to figure out how many caramel apples are covered with sprinkles. So then I have to interpret all the other different types of apples and the caramel and the chocolate and the coconut and that type of thing. So beyond that, we have to identify the relevant information. So what information do we need to solve this problem? We also have to think about, well, what information can I ignore? Sometimes there is information that's provided in a problem that's not necessary for the problem solution. So are students good at finding the relevant information and ignoring the irrelevant information? And then along with that, can students interpret information presented in charts and graphs? We don't have an example of this with this problem, but there are many problems as we look at the word problems that students are asked to solve that do have an accompanying chart or a graph, and you have to get information from that chart or graph in order to solve the problem correctly. Now I'm going to pause right here because I want you to look at these 5 problem-solving difficulties. And in many ways, when we think about these 5 areas of difficulties, students haven't really started to do the math. And so with problem solving difficulties are often more related to the setup of the word problem. So how do I digest what this word problem is asking me to do? How do I get all of the information from this word problem? But many times students probably haven't picked up a pencil and have started to do the math here. And I think that that's really interesting to think about. Now, our 6th area of difficulty is then identifying, well, which operations am I going to use? So I know a lot of you mentioned, oh, they have to add fractions, subtract fractions. We have to do some multiplication. We may have to do some whole number subtraction at some point. So there's a lot of things that students may want to think about there. And then performing that computation. So these are really some of the most common areas of problem solving difficulty. And so it's really important to keep these in mind because as we teach word problem solving, we want to always go back to these areas of difficulty and be proactive in teaching students how to read the problem and understanding the vocabulary, teaching students how to find the relevant information and how to ignore some information and how to get information from charts and graphs. And we also want to teach students to figure out, well, what are you going to do in this problem? And then how are you going to solve the problem? So I'll pause right there because I want to see if anyone has any other areas of difficulty that you have seen your students encounter. And if you have, if you put them in the chat box, that would be great. So maybe I covered all the areas of difficulty, but if you do have any more, so Elizabeth talked about motivation. So some students will just give up because they see it's a fraction. I've also seen students give up because it's a long problem that they have to read. So sometimes we do have to eliminate anxiety around problem solving and really give some students some good planning strategies and ways to get into problem solving that may not worry them. Christine adds sequencing the steps, right? Yeah, so what do you want to do first, second, third, and how are you going to solve that problem? That's going to be really important when it comes to multi-step problem solving, which we'll get to hopefully Wednesday to Friday. And Lauren, you kind of said the same thing. As soon as students see one sentence, they give up, right? And actually, there's a lot of information here, but we can really focus on some tidbits of information that can help us solve this problem. And Joanne talks about confusion with words, so really that understanding of the vocabulary. So we're going to move on here. And you've already shared some areas of difficulty for solving word problems. So thank you so much for sharing those. Now, as we talk about, well, how should we teach problem solving? So we now know where students have difficulty. So how are we going to teach this? There's two strategies that we do see sometimes used in schools that don't have a very strong evidence base. And those two strategies are using keywords and defining word problems by their operation. So here on the left side, I'm going to give some examples of this. This is a keyword poster that we'll see in some classrooms. And it's actually helpful that students know that there are all these math words, but it's not always helpful tying a specific word to an operation. And I'll show you some examples of this. So these are some examples of 7th and 8th grade word problems. So here in this top problem, I see the word each. And so a lot of times I'll kind of flip back and forth here. If I think of each as a multiplication word, if I say like, oh, each multiplication, that's not actually going to help me answer this problem correctly. But in the middle school grades, we see a lot of problems that have multiple keywords in them. And so some colleagues and I did an analysis where we looked at these word problems. And when there are multiple keywords in a word problem, students can only solve the problem 9% of the time correctly because they get confused by which keyword should I follow. So here I see total. So should I add, or I see each? So should I multiply or should I divide? And so it gets really confusing for students. Here's some examples where we see both decrease and per. And here's an example where I see half, even though it's a year and a half. A lot of students will say half. Oh, that means I'm going to divide, but then the dog gained some weight. And so what happens with these keywords is they end up being more confusing than we mean them to be. And so I'm going to scoot back here. When we think about teaching problem solving, there's really not a lot of evidence to show that using keywords and tying them to operations is a helpful word problem strategy for students. In the same way here on the right-hand side, this is an example from 7th grade. So probably if you gave this to your 7th grade students, all of them would use division. But when we look at tasks related to problem solving in the classroom or in textbooks or on high stakes tests, it never tells students, hey, in this problem, you're going to divide. And so when we teach students like, oh, these are just all long division problems, students don't have to read these problems. Students don't really have to interpret the vocabulary or think about what the problem is asking us to solve. And so it really misleads students in how easy problem solving can be when actually problem solving is a difficult task. We do have to read, we have to interpret the questions, we have to interpret the vocabulary. And so these are two strategies that we are not going to rely on today, but instead we're going to rely on, I've got to click through these again, two strategies that do have a strong evidence base. And those strategies are to have an attack strategy and to teach the word problem schemas. So today we're going to talk about that attack strategy. So you'll have that, be very confident about that by the end of today's session. And then we're going to start on the word problem schemas today. There are 6 that we're going to focus on this week. We're going to talk about 3 today, 3 on Wednesday, and then we're going to start to combine those schemas on Friday. So when we think about an attack strategy is a generalized process for working through a word problem. And there are many available. All you and your students need is just one. So if you look at these attack strategies here, these are 2 of the 10 that I'm going to show you here today. If anyone can quickly have access to the chat box, what's one of the consistent things that we see between both of these attack strategies? Read, all right. NP, got it. Shantae, got it. Deidre, got it. So You probably are here because you know that your students struggle with problem solving. And if your students in Virginia are anything like our students here in Texas, one of the things that a lot of students do is they do not read these problems. We will give a student a word problem on a page and immediately they're starting to work, and it's, you didn't even have time to read this problem before you started to work on it. And so a good attack strategy has the student, sit back, put their pencil down, and first they have to read the problem. And then everything that follows after that is just your generalized process for going through the word problem. Now, all of you as adults have a word problem attack strategy. For that word problem I showed you earlier about the caramel apples, if I would have asked, I would say, well, how did you solve this problem? Probably a lot of you first read it, so that was great. Probably a lot of you made a plan, like, okay, first I'm gonna figure out the number with chocolate chips, and then I'm gonna figure out the number with coconut. And then probably some of you would start to put these in equations. I know that because you talked about multiplying and adding and subtracting. And then hopefully a lot of you will go back and check your work. And so that's your attack strategy. And that's like what we should be doing. And as adults, it's internalized. We've done problem solving so much that we have a good idea of how to solve these problems. But for young students, they don't always have an internalized attack strategy. So we have to explicitly teach that and model it and practice it until it becomes internalized. So I'm going to show a few other attack strategies here. If I go too quickly, remember this whole presentation is available for you to go and download whenever you want to do that. So you can go through and check these out as much as you want. And let's see, so if I notice these two here, I'm going to click off there. Star, so stop and read the problem carefully. Rice, read and record the problem. Here are two others. They're a little bit longer, so I want to kind of show you some of the diversity in attack strategies. Here we have super and shines. Here we have solve on the left-hand side. That's a pretty popular attack strategy. On the right-hand side, we have cubes, which is a very popular attack strategy. A lot of schools use cubes as their word problem attack strategy. If you are using cubes, and if you haven't done this already, I would ask you to turn it into R cubes. It's not as cute anymore, but really making sure that you're emphasizing that reading of the problem before students circle key numbers, underline questions, box action words, and that type of thing. And these are great attack strategies. Actually, all of these are good. You just have to figure out which one works for you and your students, for the problems that they're solving, for the word problem level where they are working. Often schools will adapt an attack strategy that you can use, across grades 6, 7, and 8, or across grades 9 through 12. So think about, if this attack strategy works in 6th grade, is it going to translate well to 7th grade? And will that translate well to 8th grade? Going back again to that idea that this attack strategy at some point should be internalized. And so it's not something that we always have to explicitly think about, but it's just the process that guides us through solving these word problems. And then the one I'll rely on today is UPS check. In the handouts packet, I provided a poster of this. I also have a full PDF of this. If you want it, just email me. But I'll refer to this attack strategy because it's very generalized and it's very applicable across grade levels and across word problem types. So here, students will understand a problem by reading it. They will make a plan. And today we'll focus making our plan by word problem schema. Then they will solve the problem, and then they will go back and check their work. Now again, you can use the UPS check strategy. Probably a lot of you are going to use R cubes or solve or rides or ridges. There are many out there. So just have one and you're going to use it consistently. So every time you see a word problem, you're going to model how to use the attack strategy, and students should be also using the attack strategy every single time they see a mix of numbers and words, which is a word problem. So I'm going to pause right there on the attack strategy. So today I'm going to ask you at the end to share an attack strategy that you want to use. And I'm going to ask you to do this via Google Jamboard. And I'll show you just a very brief, like what this looks like. So on Google Jamboard, which whoops, there we go. All right, which the link is on the presentation, and I'll also I'll put it in the chat. This is a great way to, hopefully a lot of you are using this already, but for people to share strategies so that you can collect a bunch of strategies related to word problem solving. So I see some people are joining us already. So here with the on this page, I'd like you to put in what attack strategy you would like to use. So you go over to the left-hand side and click on sticky note. And I'd say I'm going to put in understand,
Hey,
plan, solve,
I'm
and
doing
check.
well. How are you doing?
If someone will mute their camera, that would be great. I think it's maybe Tanya that's talking. Okay. So I can add my attack strategy there. So then what we'll do by the end of this week is we'll have a really great collection of attack strategies. And so go ahead and put yours on there. All right. So someone likes UPS check. So then I can kind of move that around and put that in the UPS check collection. But if you have other attack strategies, you can either add it now, or I'm going to give you the next 48 hours to add an attack strategy. And so we'll come back to these on Wednesday and sort them and look at them there. So attack strategies are super important because they help students guide their process through solving the word problem. I'm going to click back to my presentations, but you're welcome to add your attack strategies on the Jamboard, and I'll share this information again at the end of today's session. Okay. So beyond attack strategies, we're now going to take that knowledge that we need to have an attack strategy, and we are going to combine it with a focus on what we call the word problem schemas. A schema is another word for a structure, or maybe you want to think about it as a foundation or something that's common across word problems. So it's a schema. And we're going to focus on 3 word problem schemas today. We might just get to 2 of them, which is okay because we have Wednesday and Friday to introduce some of this other information. But today we're going to focus on what we call the additive schemas. These are schemas in which students end up adding or subtracting, or adding and subtracting. And so these 3 schemas we'll focus on today are total, difference, and change. And then on Wednesday, we'll talk about the 3 multiplicative schemas that are very commonly seen in the middle school and high school grades. And that is the equal group schema, the comparison schema, and the ratios or proportion schema. Now you might say, well, Sarah, I'm teaching 8th grade, so let's just get to that multiplication and division stuff. And I wish it was that easy. That would be, we'd only have to have 2 sessions instead of 3. But what happens is in middle school and high school, most of the word problems that students solve end up being multi-step word problems, where first they have to figure out the equal groups and then they have to figure out the difference. Or first they have to figure out the total and then they have to put that into some type of ratio or proportion. And so students have to have knowledge of all 6 of these schemas, even though total difference change schema knowledge really develops in elementary school. You as a teacher need to make sure that students do understand what these schemas mean so that then students can successfully solve these multi-step word problems. So we're going to talk about the total difference and change problems. I put together a graphic organizer for you. So this is in the handouts packet. You might have it now, or you might want to access this later. Looks exactly what is here on the screen. So I'm not sure why I have to figure out, I have to hold it up for you. But here it talks about the 3 additive schemas. And then on Wednesday, I'll give out the one that has the 3 multiplicative schemas. But we're going to talk about each of these in a little bit of detail. And then I'm going to show you how we take that attack strategy and combine it with the word problem schema to help students become successful problem solvers. So we'll first talk about the total problem and the difference problems, and then the change problems. And my word problems, I've kind of kept them a little bit simple today, and that's okay when you are teaching word problem solving. But do know that these schemas are applicable across whole numbers and fractions and decimals and positive and negative integers. So let's go ahead and get started. We'll first talk about the total word problems. So in a total problem, we have parts that are put together into a total. And I know a lot of you are focused on my screen right now. I am going to use my hands to show some different gestures here, and I'll share a video with the gestures if you can't see me. But if you can also see my little thumbnail picture, I will use my hands quite a bit here to talk about these word problems. So in total problems, we have parts that are put together into a total. And your very classic in a total problem is something like this. Emily saw 4 cardinals and 5 blue jays. How many birds did Emily see? Now, again, you might say, Sarah, that math is so simple. Well, put this in, Emily ate 1/4 of chocolate cupcakes and 1/6 of strawberry cupcakes. How much of the cupcakes did you eat? Like, you can put fractions with this, decimals and positive and negative integers. It's going to be the same, but the structure is always that this is a total problem. Now, these are 2 variations of total problems. Emily saw 9 birds. If 4 of those birds were cardinals, how many were blue jays? Or Emily saw 9 birds. If 5 were blue jays, how many were cardinals? So what we see in all 3 of these different word problems is there's 3 common components. There's a part, there's another part, and there's a total. In the first story, we ask students to figure out the total. In the second and third stories, we ask students to figure out the parts. And so this common schema that is across all 3 of these word problems is the total schema. So to help students figure out, well, do I have to figure out a total in this problem? We ask a very simple question, and we ask it in the same way every time. So we ask, are parts put together for a total? And we like to use gestures to help students cue into these problems. So here for total problems, I hold my hands apart when I say parts. And then as I put them, say put together for a total, we move our hands together to kind of show the combining of those parts. So our parts put together for a total. So once students figure out, well, yeah, I do need to figure out a total in this problem, there's lots of different ways that they can go about organizing that total information. They could use an equation. So here at the top is an equation that represents the total problem. So here we've got P1 plus P2 equals T. So part 1 plus part 2 equals total. Or you might choose to use a graphic organizer. A lot of schools will do this. I think the graphic organizers are really great for students that want to organize their information in a visual way. A lot of times it's very helpful to have these graphic organizers already printed out for students so that they don't have to draw them every time. A lot of schools will have these so that students have these laminated and they can use the same graphic organizer again and again to plug in information from different word problems. Today, I'll use the equation most often, but anytime I use that total equation, you can also use the total graphic organizer. So we're going to solve some total problems. I'll go ahead and tell you, make it a little bit easy, that problems A and B on your handouts packet are both total problems. We'll solve problem A all together, and then I will ask you to work on B just independently to give you a little bit of practice with that. So we're going to look at problem A here. This is about Megan baking some sugar cookies and chocolate chip cookies. So I'll make myself hungry this early in the morning here. And I'm going to solve this problem right here on my document camera so you can see how we would teach students to solve this problem. All right, first thing, I see a mix of numbers and words. So immediately I want to get out my attack strategy. And the attack strategy that I'm going to use is UPS check. Some of you might use R cubes. I hope that a lot of you add some cool attack strategies to our Jamboard. But I'm going to write my attack strategy here so that I, first of all, remember to use it. And I like to write it vertically so it's really obvious. First, I'm going to understand the problem, then I'm going to make a plan, then I'm going to solve, and then I'm going to check my work. All right, so let's understand the problem by reading it. Megan baked 38 sugar cookies and 24 chocolate chip cookies. Enter the total number of cookies Megan baked in all. So what do we have to focus on in this problem? Well, let's see. I have to focus on cookies. So I'm going to underline cookies. And I might want to underline a few other things, but one of the things we want students to really be picky about is not underlining or circling or highlighting all of the information in the problem. You probably know or have seen this, but we'll ask students to, well, underline the important information. And what do students do? They underline everything in the problem. So here I just want to focus, okay, I'm focused on the cookies. So I have to figure out the total number of cookies Megan baked in all. So I've got a general understanding of this problem. So I like to check off that I've done that part of my attack strategy. Now we'll make a plan. So I'm going to ask myself, is this a problem where parts are put together for a total? And yes, it is. I see I've got sugar cookies and chocolate chip cookies, and I put those together for a total. So my plan is to solve this as a total problem. So remember I talked about that total equation, P1 plus P2 equals T. I could also then quickly draw, if I wanted to, my total graphic organizer. But the idea is that once we identify what the schema is, we go ahead and either write the equation or draw the organizer so that students can remember to solve this part of the problem as a total problem. So I've got my plan. Now it's time to solve the problem. Megan baked 38 sugar cookies. 38 is a number, so we stop. We ask ourselves, well, does 38 tell us about one of the parts or the total? Well, here, 38 tells us about one of the parts. We like to check it off so we don't use it again. And I'll just write it here in P1. If I was using my graphic organizer, I could write 38 right there. Now she has 24 chocolate chip cookies. 24 is a number, so we stop. 24 tells us, does it tell us about one of the parts or the total? Well, 24 tells us about another part, so I'll write that underneath P2. And if I was using my graphic organizer, I would write 24 right there. And then enter the total number of cookies Megan baked in all. Well, we don't know that. So I could mark this with a question mark. Maybe I want to mark it with a C for cookies, an X, many different ways that we could mark that. But now I have my missing information marked. And I'll put in my symbols and I'll go ahead and solve this problem. So 38 plus 24, I'm going to do the math here. So C equals 62. And I like to put a label on this numerical response. So 62 is talking about, well, what did we underline? Cookies. So 62 cookies is how many cookies Megan baked in all. And if I was using my graphic organizer, I could see a 38 plus 24 combined to equal 62. So another way to use the graphic organizer. So I've solved the problem and now I want to check my work. So we could do 62 minus 38, 62 minus 24, does that equal 38? There's lots of different ways that we can check our work, but at the end, students check the check mark to show that they have checked their work. So that's a generalized process for working through a pretty simple total problem. Remember, we're starting simple so that we can build to more complex problems. But I'd like you to, and I'm not going to give a lot of time for this, but I'm going to give about 1 minute or so to look at problem B. If you can, start to think about what's your attack strategy, and then how would you help students solve this problem about the rain in March and April. All right, so I know I'm watching the clock and I want to move us forward, but I want to just talk about one thing here in this problem. So here we're solving for one of the parts, the April part of rain. And so if you set up your equation or your graphic organizer, you get to this point right here. So some of you might do 11 and 4/10 minus 3 and 9/10 to figure out how much it rained in April. But others of you might figure out, well, what can I add to 3 and 9/10 to equal 11 and 4/10? And so in this way, I couldn't say to students, hey, this problem today is a subtraction problem, because some students might use subtraction, but others might use addition, in the same way that I couldn't describe this as an addition problem, because it ends up being that the operation could really depend on, the math knowledge of the student and what they're comfortable with. So instead of saying it's a subtraction problem or an addition problem, the better way of describing this problem is that it is a total problem. And that's why the focus on schemas is really important there. All right, so I'm going to move back to our presentation here, and we are going to leave our total problems and we are going to come to difference problems. So at the end of today, I'm going to ask you to present a total problem that your students might have to set up and solve. So I want you to start to think about what that example might be. All right, so we talked about total problems. I do want to say that sometimes people also call those combined problems or part whole. There's lots of names out there for the same schema. But the next schema that we're going to talk about is the difference schema, or what we also call the compare schema. Now, in a difference problem, we have a greater and a lesser amount, and we compare those amounts for a difference. So our very typical difference problem is this. Sinead has 9 apples, Amanda has 4. How many more apples does Sinead have? Or the question could ask, how many fewer apples does Amanda have? Or a very common question is, what is the difference between Sinead's and Amanda's apples? So I am sure you have seen that question asked in some way, shape, or form. And so in a difference problem, we have a greater amount and this lesser amount, and we compare those two amounts for a difference. Now, while a little bit more unusual, we do see students have to interpret the word problems in this way. Sinead has 5 more apples than Amanda. If Amanda has 4, how many does Sinead have? Or Amanda has 5 fewer apples than Sinead. If Sinead has 9, how many apples does Amanda have? So in all of these 3 word problems, there are 3 common components. There's a greater amount, a lesser amount, and a difference. In the first story, we're asked to figure out the difference. In the second story, our job is to figure out the greater amount. And in the third story, our job is to figure out the lesser amount. So once we think about, well, we've introduced total problems, it's then helpful to introduce difference problems and a question and a gesture that goes along with those. So for difference problems, we should ask, are amounts compared for a difference? And we like to hold up, at one hand a little higher for a greater amount, one hand a little lower for the lesser amount, and then we kind of move our hands back and forth to think about the difference between those two amounts. And then once students figure out that there is, this is a difference problem, we think about using a difference equation here, G minus L equals D, or greater minus lesser equals difference. Or these are 2 examples of difference graphic organizers. I've also seen teachers use others. So if you have some type of graphic organizer that represents this schema, you can also use it as well. And I know Ian said, I think it's Ian, it's not Ian, but it's the person that's representing Ian's account said that they like to use the graphic organizers. And so here are some examples, and I think you might have more to share as well. So let's look at 2 difference problems. I'm going to look at problem C, and then I'm going to ask you to quickly look at problem D. So I will get my marker out here and I'll scoot my problem up and we'll work on this problem right here. Okay, so in this problem, I see a mix of numbers and words. And so that is a word problem. And I want to attack that word problem. So I'm going to get out my attack strategy as quickly as I see that I'm going to need to use it. So I'm going to understand the problem by reading it. Jenna has 162 wooden beads and 95 glass beads. How many more wooden beads than glass beads does Jana have? So in this story, I have to focus on the wooden beads and the glass beads. So I'm going to underline that information. And it looks like I have to figure out how many more wooden beads than glass beads. So I have to compare them. So I've got a basic understanding of the problem. Now I need to make a plan. Well, I'm going to ask myself some schema questions. Is this a total problem where parts are put together for a total, or is this a difference problem where amounts are compared for a difference? And so here I can see that this is a difference problem. Let's see, here we go. This is a difference problem. So I'll quickly just write my difference equation, because then that will help me organize the information from this difference problem. And I've got my plan. I'm going to solve this as a difference problem. So now I'm going to solve the problem. Every time I see a number, I want to stop and talk about whether I think it's necessary to include that number. And then if it is necessary, is it the greater amount, the lesser amount, or the difference? And just because we're short on time, I see that 162 is the greater amount, 95 is going to be the lesser amount because I'm comparing those. And I'm going to solve for the difference. So then I would do the math here. And I don't remember the answer to this one off the top of my head. Just a case of the Mondays, I guess. So I'll go ahead and do my math right there. So question mark equals 67, and I'm comparing, so I have 67 more wooden beads. Go ahead and put my label there. And then I want to check my work. So I could check that 67 plus 95 does equal 62. I could do 162 minus 67. Does that equal 95? Several different ways to check my work, but I do just want to make sure that I have checked it. So I'm going to push pause there because I'm looking at our clock and I want to make sure that we finish up on time and we make sure we've got our work set aside for Wednesday. So this problem D here is an example of a difference problem. I hope you would look at it and figure out, what makes that a difference problem and how could students solve that problem. And then I want you to think about, well, what makes a difference problem a difference problem? So did I do my math incorrectly there? I think I'm okay. All right. So I'm going to leave change problems to Wednesday, and that's okay because I want to make sure we have our assignment for this week. So before Wednesday, I would like you, I'm going to say, I'll actually change this in real time. All right, so we're going to do 2 problems. There we go. Okay. So I would like you, let's see, hold on, sorry. I've got to get my share screen up here again. So I would like you for Wednesday to write 2 word problems. We're going to go to our Jamboard. So that's, well, I'll go to that in a minute. I see some people are already adding a lot of attack strategies. That's great. That looks great. But on our Jamboard, when you go over there, at the very top, you see that there's 4 screens here. So over here are total problems. So by Wednesday, I would like you to be reflective and give me a total problem that your students might have to set up and solve. You might want to look at some of your materials. I always look at a lot of high stakes test release items, and the total problem might be embedded within a problem, but it will be there. So what kind of total problems are your students expected to solve? And then in the same way, what kind of difference problems are your students expected to solve? We'll leave the 4th one, change. We'll leave that for Wednesday. We'll get to that Wednesday. But also continue to add here to the attack strategies. I want to see what type of different attack strategies you all are using. And then this will give all of us a really good idea of some of the more popular ones and why those might be important to use for students. I see buck. Oh, I like that. I see ride here. Got a lot of people are using ride. So your job before Wednesday is to go to our Jamboard. I'll go ahead and put the link here again in the chat if you don't have it. Write your 2 problems, your total and your difference problem. And then it says design an attack strategy poster, but I'd really just like you to add your attack strategy to the Jamboard so collectively we start to put together a lot of really good word problem ideas. So that's all I'm going to share for today. I'll finish with 1 minute to spare and turn it over to Cami. And then I'm looking forward to seeing all of you Wednesday. Well, we'll start with change problems, then get to the multiplicative problems, to then head into multi-step problem solving by Friday.